let me start by congratulating Giancarlo for the prestigious academic position that he has accepted. And conversely, let me congratulate Roel and the University of Twente for hiring a very distinguished academic. The topic of my presentation is explainability. And the way I chose that topic is we are doing work. Sorry, Giancarlo is doing work from a different perspective on the same topic. And also explainability relates to work that we have been doing with Giancarlo and Renata and Glenda Amaral on trustworthiness and ethicality requirements. What I'll be presenting is ongoing work with Alex Borghita and Sotirios Gliaskos. So there is a lot of interest these days in explainable AI systems, and the reason for this is that both governments and the public are interested in making these such systems accountable. Now, accountability means answering questions about one's performance. Explainability is a more specific quality for such systems, which concerns answering why questions about the system's actions and goals. And there is interest actually not only in explainable AI systems, but also other kinds of systems as well. Any system that handles personal data is should be able to explain what it's doing with this data. I guess that's a European law right now. Now, there are three types of requirements for a system to be. There are functional requirements and quality requirements that people generally talk about, but there are also content requirements, which are talking about the kinds of information that the system should have access to in order to fulfill its purposes. And for example, any information system has content requirements that basically ask what kinds of information should the database contain, so that it can handle the queries that people. There is work on explainability, at least in the requirements engineering community, and all of that work, as far as I saw, treats explainability requirements as quality requirements. For our purposes, we are going to treat them as content requirements that are defined by a set of competency questions. I'll give examples of that. So these competency questions are why questions. So they ask, for example, for an autonomous vehicle, the passenger may ask, why did you just slow down? And a possible answer may be because I want to maintain a safe distance from the car in front. And why do you want to maintain a safe distance from the car in front? Because one of my goals that I'm pursuing right now as I'm driving around is to drive safely. Or if we're talking about a chat doctor, where the patient gives his symptoms and he gets a diagnosis about what his problem is, and if the patient asks, why do you think that I have cancer? Then the answer could be because this is the most common cause for your symptom. here the answer doesn't refer to the goals that the agent has who did the diagnosis. Instead, it relates to medical science and what it knows about for different types of disease, what are the symptoms that that apply. Right. So explanations. What are explanations? Well, explanations provide causes for something. This has been discussed as far back as Aristotle, who distinguished 4 different types of causes. 2 of them don't really apply in our modern context, but the other 2 do apply and are interesting. So, for example, why did the ball drop when I let go? May be answered in terms of gravitational force, a particular type of force, and Newton's second law. These are the reasons why the ball dropped. We are interested in explanations of 2 kinds. The first is relates to causes that consist of the purpose or the goal or the intention behind an action that the system is performing. These we'll call teleological goals, and also laws, rules, or including design rules that apply for the action or that we are discussing. And these are called canonical rules. Sorry, canonical explanations. So, for example, if I have a question such as why did you turn, asked of an AV, autonomous vehicle, this may be answered because I need to recharge my battery. So I want to get off the road to go to a charging station, or this is the teleological reason. You give the reason, the explanation gives the goal behind the turning. And the other possible explanation is because I turned the steering wheel, which is the canonical. I mean, a car by design turns whenever you turn the steering wheel. Okay, so what I have described before basically says that explainability is an epistemic problem. To the system, we need to provide explanations to why questions. And in order for the system to do this, it must know the goals and rules that explain its actions. Now, I*, which is a requirements modeling language proposed by Eric Yu, captures the requirements for a system to be, including stakeholders involved, their goals, their tasks, or actions, through which goals can be fulfilled, delegations of goals and tasks from one actor to other actors, and things like that. These are the kinds of concepts that you have available, and so that you can talk about the different goals that different actors have, and who is responsible for fulfilling the goals, because it may not be the same stakeholder. So we are going to adapt I* in order to capture the informational need, the information that is required in order to answer the competency questions that I was talking, the why questions that I was talking about before. And the models that we're going to build are going to contain both class knowledge or concept knowledge, like the goal of scheduling a meeting, but also instance runtime object information, such as a particular request for scheduling a meeting and the actions that the system performs in order to satisfy this goal. This is a simplified example of for meeting scheduling, where you have a goal at the top, meeting scheduled. It's refined into three sub-goals and sub-goals: timetables collected, time slots selected, and good participation. Good participation is a quality goal or non-functional goal. And then timetables collected can be done in two ways: by email or from a timetable database, while time slots selected can be done by manually by asking, for example, the initiator, the person who requests a certain meeting, to choose a time slot on the basis of all the timetables that have been collected, or it can be done by the system. And then for good participation, we have one soft goal that contributes to it: minimize conflicts. If you minimize conflicts, this helps in fulfilling the goal of good participation. And the other is offering cookies, which is a functional goal. I mean, you are going to, there are some actions that are going to be carried out to fulfill this goal. And in both cases, these are contributions, are positive contributions. They help in the fulfillment of goal G3, good participation, but they don't necessarily satisfy it completely, because it's not, I mean, good participation, there is no such thing as full satisfaction. It's not clear what full satisfaction means. Now, this is a very simple model. In our past work, we have much more sophisticated models, even for a simple meeting scheduling problem. And the important thing to note here is not only there are more options in terms of alternative ways of satisfying goals, but also there are a lot of other soft goals, such as avert annoying participants, quick scheduling, maximize attendance, reduce labor, and I mean human labor involved in scheduling and the meeting, and so on. And this is the other type of diagram, that social dependency diagram, that describes here three actors: initiator, scheduler, and participant. The scheduler is presumably the system that we are designing. And there are three dependencies. The initiator depends on the scheduler to fulfill the goal of scheduling a meeting. The scheduler depends on participants to provide timetable information. And the participant depends on the initiator to have a useful meeting. And this is a non-standard notation. It is not what I* modeling language uses. This is a simplification, just so that I can draw it on the in PowerPoint. Right. So we are, I said we adapt I* as a modeling language, but we really have to extend it. First of all, in order to be able to talk about runtime objects, since the explanations are going to be requested and pulled together at runtime as the system is running. So because the explanations are going to be about particular actions that the system performed, such as sending a request for timetables to one of the invitees, the people who have been invited to the meeting, and things like that. And there is earlier work that we have done with Alex Borghita, Fabiano, and Jennifer Horkov, which basically we have extended so that we can talk about runtime models of I star or I plus classes. Right. So the other thing is that we need to make sure that the I star model that we have for the requirements for the system, the functional and quality requirements for the system, they do provide for the different types of instances that our competence models talk about. So if there is a competence question that asks, why are you asking me for timetables for this period? This is talking about a particular email action that the system performed, asking that person to provide his timetable for a certain period. So this means that there should be a class that talks about whose instances are the particular actions that are performed by the system when it is sending email to all the invitees. We also need to be able to talk about causal relationships because, well, I guess that would be very useful if we're trying to produce explanations. And also need to introduce temporal constraints. This is some work that is in the Diaz and others paper. Temporal constraints, for example, for all the sub-goals of an AND refinement, we need to provide what is the temporal ordering of fulfilling the sub-goal. Right, so here are some examples of competency questions or why questions. The first one, why you need my tables for this period, and the answer may be we expect not only competency questions, but also expected kinds of answers. So the expected answer for the first one is I'm scheduling a meeting requested by initiator for a particular purpose. So this means that the system needs to, in order to generate this kind of explanation, the system needs to know who is the initiator and who is the purpose. What is the purpose of its meeting? So why do you need timetables to schedule meetings? And the answer may be time slots are chosen to minimize conflicts, and conflicts are found using timetables. Note, this is not a question about instances of goals or actions. It is a question about the conceptual model that the I star model that I showed you earlier. But nevertheless, in order to answer this question, we must know on that conceptual I star model, we must know where are timetables used and why did you choose one time slot instead of another time slot? And the answer is because this is the criterion that I'm using. I'm trying to minimize conflict. Or why was I invited? And the expected answer is because of selection criteria. So this means the system has to know selection criteria for each meeting that is being requested. So on the basis of this, if these are the explainability requirements, for the meeting scheduler, then we have to extend the I-star model that I showed you earlier to something like this. The new extensions are in brown, so we need to talk explicitly about a meeting request, and in particular, we need to specify what kinds of information the initiator has to give in order to which is going to be used somewhere in the system. And that information, so it is by the initiator, and that information is the purpose of the meeting, the invitee list, and the selection criteria for the invitees. And at the bottom of the slide, you see that we have goal G4 that is talking about collecting timetables by email. And now we have, we refined this into N sub-goals, and refined this into N sub-goals that are have that all look like G10, except so timetable collected from invitee I, where I ranges from 1 to N. N is the length of the invitee list. And each one of these sub-goals is satisfied by a task request timetable from a particular invitee. And at the other end, we have a task for selecting by the system. This is the task T2 on the lower right-hand side. Well, my right-hand side. And finally, what you see here is that the goal G1 is related to answering two explainability questions, 1 and 4, namely 1 and 4, while the T2 relates to XR2, sorry, explainability requirement 2 and explainability requirement 3. Right. Now, one of the things that comes out, I'll hurry to finish in a couple of minutes. One of the things that comes out is that we need to have rich descriptions of things that matter in the operation of the system. For example, for the example that we're discussing, we have timetables. And so we need to describe for timetables what kind of information they contain. They should contain information so that one can determine conflicts between a time slot and a particular invitee. I'll skip the other example. And finally, we have to make clear the information flow in the system, because that's what counts when we are generating explanations. So, for example, so we have to extend the descriptions or augment the descriptions for every goal and every task, so that you have in and out parameters that tell you what kind of information does this task or this goal generate, and what kind of information it uses. Right. So for meeting requested, the goal G1, we have information that is generated, such as the purpose of the meeting, invitees, time slot, and time period and time criteria. While for the task select time slot, we have this uses information about the invitees, the timetables, and the time period, and generates a time slot. Right. So what we have observed is that this idea that the system collects information so that it can generate explanations at runtime. This seems to apply to other competency questions beyond why questions. So, for example, look at explainability requirement 5. Did you invite any additional participants after choosing a time slot? So now, remember that somebody asks for an explanation relative to his understanding of what the system is doing or what it ought to be doing. So what is being asked here is that if there are too many conflicts, so this means that many of the invitees are not going to participate in the meeting, then what the system should do is after it selects a time slot, then it invites some additional people to participate for that time slot that has been settled. And so in order to handle this kind of question, we need to extend the requirements, the goal model that I showed you earlier, to add another sub-goal to meeting schedule, the top level goal, and so on and so forth. Right, so in conclusion, this is ongoing work, which I'm sure you have already observed. And the important things that we have done so far is, in the first place, we decided that explainability requirements are not going to be treated as quality requirements. They are going to be treated as content requirements, informational requirements on the system. And then basically, we have to extend the I-star model so that they specify what are the informational needs of the system and where it gets them from and where it uses them in the out of these kinds of models, we feel that we can generate the desired explanation. And perhaps the most difficult task ahead of us is to understand better the scope and limits of the proposed solution that we have to generate. What can we handle things beyond why questions? Okay, thank you very much.